All right, so let's talk a little bit about our actual regression line equation. So the equation that we just saw in the previous example had to be obtained from our data set somehow. So that's what we're going to look at in this section. So if we're thinking about this, again, we're tying back to things that we've seen in algebra before. So I'm just going to make some little notes up here at the top. Right? So when we're thinking about a basic algebra course and we're thinking about our equation of our line in slope-intercept form, we write as y equals mx plus b. Right? Now, when we're doing statistics, right, notice that this is written as y equals a plus bx. So what we've done is we've switched letters here. Right? So what we've done is we've basically just taken this equation and we've flip-flopped these pieces. So I'm going to rewrite this as y equals b plus mx. So I'm just going to switch the order of that side of my equation. What that means is the letter b in our original algebraic equation, which is our y-intercept, well, that's now going to be represented by the letter a. And our slope in our original algebraic equation, which is the letter m, that's going to be represented by the letter b. Okay? So as we're doing this, again, we want to connect it back to things that we've done before. So again, this a is going to be our y-intercept, and this b is going to be our slope. All right. So our regression line equation is y equals a plus bx. All right, now, what we need to do in order to find these, we're given our slope, and our slope is b. It's r times sy over sx. So it is r, our correlation coefficient, times sx. That's our standard deviation of our x-coordinate. Sy is our standard deviation of our y-coordinate. And then our y-intercept is given a equals y bar, which is our mean of our y data set, minus b, which is our slope that we just found, times x bar, which is our mean for our x data set. Right, in StatCrunch, the good news is the regression line information that we found in the previous section to find our correlation coefficient, we do the exact same calculations here. So as we're thinking about this, we're going to kind of connect this. We're actually going to use the same video for both sections because we're using the same data set. And then once we get all of that information, we'll continue to talk a little bit about that. All right, so the figure shows the association between the height and weight of a sample of 6 women. The original data set is listed below. So this is the same data set that we were using in the previous section. We had height and weight for 6 different people. Right? We are given the mean of our height is 64, and our standard deviation is 2.608, just as we were in the previous section. We're also given our mean of our weight and our standard deviation, just as we were given in the previous section in section 4.2. Right? So now we're asked to find the regression line that predicts the weight using the height. All right, so let's start with our slope. All right, so our slope equation from the top of the page, b equals r times sy over sx. All right, so we're going to plug in values. I am going to make a little note here that we found r to be 0.881. Right, from our 4.2 example. So we are going to need this for our formula as well, but we'll just say that we're carrying that over from our example from the previous section. All right, so we're going to plug these numbers in. So r equals 0.881 times sy over sx. So sy 26.728 divided by sx 2.608. Right, as we're plugging it in, use parentheses carefully and or your order of operations carefully. this is going to give us 9.029. So there is our slope for this equation. Right, we must find our slope first. Once we find our slope, then we can find our y-intercept. Right? A equals y bar minus b times x bar. Again, that's coming from our formula that was listed at the top of the page. So we're going to plug in what we have. Y bar, our mean of the weights was 135, minus b, which was 9.029, times x bar, which is 64. And this is going to give us negative 442.856. Again, as you're working through these problems, just be careful with your rounding. Make sure you're rounding to the appropriate number of decimal places. A lot of times you're going to be asked for either 2 or 3 decimals depending on the problem. All right, now that we have our slope and our intercept, now we can find our regression line equations. Right, remember our regression line equation for statistics, we write as y equals a plus bx. Right? And then when we write this out, since we aren't just in a normal algebra class where we're using y's and x, we're talking about our actual variables, we're going to use words for our variables. So y was our weight if we go back up here. So we are going to write weight equals a. Right? A is our intercept that we just found, negative 442.856, plus b, which is 9.029, times our x, which I'm running out of room here, is our height. Squeeze that in the best we can. All right. So finding our regression line equation, right? We start with our means and standard deviations and our R value, our correlation coefficient. And then from there, we find our slope first. So first we find our B. Once we have that, then we can find our y-intercept, which is our A. And then once we have that, we can go ahead and write out our equation. Again, as we're writing out our equation, we want to use our names of variables, not just the actual variables x and y.